Hello and welcome. I'm Bill Wake. We're here today working on the Elm interpreter written in Swift, and we're up to working on tuples and printing types. Sorry, let me fix that. Okay. Let's see. We left off. Um, we've got tuples basically working. So tuples are anonymous records. Um, I imagine you've used them in Swift since if you're a Swift programmer. Not all languages have them, but basically I think of it as a record without labels for the fields. So we can see the real ones in the REPL. So if I do 1, I get one number. If I do 1 comma 2, I've got this structured value. It's sort of a list of things. It's not a real list. They can be different types. Let's do 1 comma 3.0. Okay, number and a float. It can have an arbitrary length. Um, whatever types you want in there. Well, oh, 2 or 3 items. Okay, I didn't know that. Okay, so tuples go with 2 or 3. Wow. Um, let's make sure. Oh, got something we can look at. We don't enforce 2 or 3, so that gives us something new to work on. Let's put this on a new tab. Okay, go. Yeah, go to the compiler. The largest tuple is 3. Okay, well, let's add that to our to-do list. Tuples may only have 2 or 3 values. Kind of a limited use thing. Interesting. There's a thing I learned way back when I worked at a compiler group years ago at Digital, back when DEC was the thing. And there was a rule that says 0, 1, infinity. Basically, if you allow 0 of something, that's fine. If you allow 1, it's reasonably easy. If you allow infinity, it's okay. But if you want 2 or 3 or 7 or some weird number, that's harder than infinity. And we're kind of going to get that. We have to enforce that now. All right. But, all right, let's go back to the REPL. Learning things left and right here. Okay, so we have these tuples. Tuples can only have two or three values, but this one has 3. Let's see if we can make one that's 4. All right, they're all each item has 2. So I have 1 plus a tuple, and then 2 plus a tuple, and a tuple of 2. So even though I have 4 values embedded in there, it's legal. All right, and I guess that's what I wanted to show was this 1 2. Notice it prints the value 1 2 and then colon and then the type. Same thing here, 1 2 3 type. I'm not going to address the number 1, number 2 thing yet. I think that's basically um, saying these are generic numbers, but they don't have to be the same. Okay, there's nothing trying to make them the same. So when you do a floating point add, you want you want if it's an interfloat on the left plus a float, you want the result to be a float. So you're going to conform those two types to each other. Number does conform to float, so it's not a problem. Um, but in this case, these things don't have to conform to each other. And if we had one that was 1 2.03, it would come up float, but it would be, it would still be compatible with this one in the sense of number, that we could interpret the 2 as a float, but without requiring us to interpret the 1 as a float, So, yeah. All right, we can nest them, so that's kind of interesting about them. Um, and we can mix the types. Okay, so the thing I wanted to focus on today is it it's first visible in tuples, but it sort of affects the others. The deal is that our printer for our type, in this case for the 1, it prints the value and the type. And for us, our printer for the tuple does the same thing. Well, no, our printer for the tuple prints 1 : number inside here. So let's see if we can. Let's run that. So our printing has the type embedded in the value, and when you have a flat value like we had with 1, evaluate 1 number, but 1, 2. Well, the word tuple we can get rid of. That's not a problem, but notice the internal types are there instead of being able to say : number, number. So I'd like to fix that, and fixing that is going to affect everybody because right now our interpreter just says print the value, but really what's going on is print the value and a colon and print the type. And we don't do it that way. So we have some unwinding to do. And I'm not sure the best way to go. It's not very many, so I'm willing to kind of leave them on the floor a little bit. Yeah, let's see what we can do. So here's our interpreter. This thing calls evaluate input. I think I'm gonna make it. Let's let result equal this. And we'll print result. And that's just a little extract variable, no impact. Well, our tests don't cover the view model stuff yet, so that's yeah, I'm not sure. Okay. Now what I want to do well, if I do this result : result dot, come on, /result dot, well, oh, not result. Oh yeah, it is result. Append. What's the type? Oh. Our interpreter produces a string. Interesting. Okay. What we learn, okay, it produces a string. Well, I'm going to leave this like this. Whoops. Okay. Even though it looks a little weird, this outside. Okay. A little too much help there. Even though it looks weird to print something that is a string, I think this is the right next step for this. Okay. I don't think it's going to break anything, so we'll just do a manual test. But what I'm realizing is interpreter evaluate probably should produce an expression for us, and then we can print the expression and print the type. Instead, it produces a string, which is handy for some things, but not so much for others. So let's see, 1 should come back as 1 number, and 1, 2 should come back as 1, 2. Okay, tuple. All right. Well, this is really pushing me somewhere I didn't think I'd have to go. Okay, so interpreter tests. So evaluate is expecting a string. What do we want to do? I mean, I could see saying print returns a string, and you should call that Where's interpreter? Give me a string, I produce a string. I parse it, that's fine. And I evaluate it with a symbol table that I maintain. Okay, and I return the result.description. Okay. I would like this. Well, I'm going to do it another way. How am I going to do this? I don't want to call that evaluate. I want to evaluate to return an expression. So I'm going to rename this. And I don't know, my best name right now is print. So let's call it print. Oh, no, there aren't very many uses. I thought there would be more. Okay. And then I think this result, his type should be expression. Yes. Okay. So let's extract this. Oh, come on. You can't extract that. Okay. Well, it's taking in an input. We'll do it manually. So the manual way is create the header. All right, copy in the body. Figure out, well, we need a return, which is result. Okay. Are there any other parameters coming in? Well, symbol table comes in, but that's a field. And everything else is computed locally. All right. That all looks good. We can replace this. If we want to be careful, we do it like this. Okay. And we'd say let result equals evaluate of input. And see if everything still passes. All right, and this is not super deeply tested, but we do have evaluate. Okay, now let's find the callers of this and see which ones should be calling evaluate callers. There's not very many. Okay, interpreter view model, interpreter.print. Well, we're going to work on that one. There's a test, yeah. Okay. Yeah, that's sort of okay. We'll work on things. Okay, so now I think I can make my switch. So if I call evaluate of input and then I print result.description. All right, I think that's going to look the same as we have, since print just prints result.description. It starts up so fast. I'm not used to it. Okay, 1, 1, 2, 12, 2. I also want to strip that extra new line. Okay, but it seems to be doing what it did. All right, let me add that to the to-do before I forget. Trim input. Okay. All right. So we have the interpreter now produces. Evaluate produces just the expression. Okay, I'm going to inline this. Okay, and I'll just write those. All right, so what we've done is we've started splitting up. Well, we did split up Okay. Now, let's go look at our types. Type. So the printing of the types. Right now we print number float. That's fine. Custom type, just its name. And okay, we got the function, and then the tuple is the one we're not happy with. So, where's that word tuple coming from? Interesting. Oh, the tuple printer, not this. All right, so this prints inner types. So I think that's okay. It's printing, that will be number or whatever. Okay. So I think this thing is printing what we want. So let's see if we can do that. I'm feeling like we could make some tests out of this. Okay. All right, let's copy this. We want to say interpreting an expression prints its type. Okay. And that's going to change this a little. Well, I think what it's going to do is print it twice. And we'll live with that for the moment. Okay, so this logs into session. I guess input is nothing. You type in 42. Okay, I think you're going to get that. Let's test that. Should fail. It's not what we want in the long run, guaranteed. Okay, these fail. They're the only ones that fail. That's good. Okay, 42 number does not equal 42 number. Right. Okay, so let's make our interpreter view model. Now it prints the description of the result. And space colon space. Let's take that into account here. Okay, I guess I wasn't consistent. Great. Space colon space, and now we want result dot type dot, what do we call it? I lost it. Elm type dot format type. I think that could become description too. Format type. All right. I think this will pass that test now. Okay, now let me put my to-do. Let me mention that format type thing because I'm going to forget it. Okay, format type goes to description. All right. We're printing out the number twice. I don't want that. I want it to do this. Okay, now these tests will break, but I got other tests I want to break. And it's a weird thing because it's like, it's sort of exactly what you get sometimes with bugs, but you know, if I fix this, it's going to break that. Okay, so I have to either get all my tests coordinated, or I accept that passing this will highlight the tests that should fail. And what I'm going to do is I'm going to try and catch them all. Okay, so here we go. The test as string I'm saying that integer as string should not be printing the type with it. All right, so where's integer value? Okay, his string does the value and the format type. We don't like that. Okay. So let's get his tests, wherever they went. Integer value tests. I'm gonna alphabetize this yet. It seems like such a good idea to be able to organize these things, but when you have a bunch, which maybe you're not supposed to do, but whatever. Okay, integer value tests. Let's lock that one in too. Anything that looks like a printout. I really think this should just print 739 now. Okay. And let's test. Everybody should fail all three. Right? As string. And the two interpreter tests. Good. Okay, so I want to do integer value. I'm going to take this out of here. All right, so I just returned the value, and I think all my tests should pass. Okay, we got new tests failing. Let's see what they're expecting. Yeah. So the closure test relies on the colon number. I think we can say this is... I think we can do this. Function call test is variable number. And I'm calling, what am I calling? Function. I'm just calling the individual pieces of our stuff. Anybody who was printing out integers, relying on them, is now affected. So I'm sort of using both methods, unfortunately. And this is more debugging info at this level, so I'm not too bugged by it. Interpreter test, so that sounds funny. Interpreter evaluates and prints. Prints value. Okay. And one more down here, I think. As string. Yeah, that's an easy one. Oh. This editor is so crazy. Okay. Lambda name 3. All right. Now I think they should all pass. One more holdout. Interpret if as string. If true bool 3.25 float isn't equal to if true bool 3, 2.5. What? Oh, did I guess for now it should be float. We haven't dealt with float yet, so we'll be touching this one again. All right, now let's check that in. So I know it's a little intermediate, but it's a lot of stuff. So make it so integer value doesn't include the type in its description. Okay, and so we just want to go systematically through these things. Elm types, integer value, float value. We're going to do the same thing. take that off. This time I'm going to look for, I'm going to look for colon space float. All right, not a lot. We already were here. Three 2.5. Okay, and this should be failing 2 tests. Okay. Yep. And float value test. Yep. Okay, so we'll fix float value. I guess I can close integer value. Interpreter float value. Description no longer includes the type. And that makes me feel like there's probably something simplifying we could do, but maybe not. Okay, and should pass. Okay, we removed type from float value description. All right, we did integer float, custom value. Same thing. I guess, where's custom value tests? Custom value false, we expect this to go down to that. Should fail. Okay. Custom value. Yes. Okay, and where's custom value? I really, if there's a way to turn off this thing where it makes tabs temporary until you double click them, let me know, because it drives me bananas. All right. Should pass. Oh yeah, our old friend. If true. Oh yeah, we got rid of that one. Okay. So we get kind of this mix. I try and get them all and run it, change it. It makes the ones I thought I got right, and then anybody I missed, it catches. So I guess it's good in a way. I mean, it means something is, let's see, I'm just going to close these others. It means something is, that I've got the tests on these things. So that's something. Make me feel a little better. All right. Custom value. I didn't check that in. Okay, let's do that. Remove type from custom value description. All right. Next one down, if expression. Well, this may not be a deal. We may not care too much. Whoops. Let's get if expression tests. I think we've already done the work. Yeah. Okay. And if expression, we want his print as string if this else that. Yeah, that's fine. Definition. Well, we don't even have an as string for a definition yet. That's a little weird. I guess we didn't really quite do all that. That's a separate class variable. Just the name. Lambda expression, lambda name expression, okay. Closure, I think was okay, yep. Function call. Arguments, okay, and tuple. Tuple as string. Now that's a different one. Okay, so we're caught up, except for tuple. Well, we don't want, how do we want a tuple to look? We don't want the word tuple there. Well, no, let's find the test for it, sorry. Okay, tuple. Evaluate. That is correct. We're not testing the as string though. Well, let's add that. Test as string. And I'm going to take this complicated one. Maybe we'll trim it up a little or something, but let's make a float value in here. 3.0 elm type dot float, just to kind of mix it up a little bit. Okay, and so if we say assert equal, and we want value dot as string to be, well, we got a 1. Let's see how they space it. They put the values right in there, no spaces. Okay, let's do that. A 1 with, sorry, I didn't look close enough. Yeah, they don't put any spaces anywhere. What if I do? Nope. Okay, no spaces. 1, comma, and then inside is a tuple that's 2, comma, 3.0. Let's see. This tuple is a 1. Oh, I'm getting myself balled up. Okay. Where are the braces matching? Okay, that one goes with that one. This tuple has 2 values. Oh, his types here. That's fine. We don't care about the types. 1, comma, 2, comma, 3.0. And that's his type at the end. Okay, so that's a complicated expression, but we're ignoring the types. We're just getting the value as if returned from some computation or something. All right, and we're just printing it. But we need one more parenthesis. Okay. Now this should break. Okay, is not equal to. We got the word tuple in there. We got spaces, and we're going to get that stuff out. Okay. No tuple. No spaces. Inner values. Oh, we join them with a map. We don't want a space there. Okay. Run those tests. Good. All right. Let's run it once manually just to convince ourselves we're totally safe. Oh, already running? Okay. 1, comma, 2, comma, 3.0. Evaluate. Okay. 1, comma, 2, comma, 3.0 evaluate. Let's take this. Oh, I can't copy and paste out across. Okay, we'll do it manually. 1, comma, 2, comma, 3.0. Okay, well, I'm willing to forgive the 3.0 versus 3 thing. Yeah, I'm willing to forgive that for sure. Number, float. They use number 1 there. We haven't dealt with the generic whatevers. Okay. It makes me wonder how Elm is dealing with these operators that need to be like convert both to the same type or whatever. But at any rate, we are good. Okay. Make tuple print as we want. Okay. I thought this would be a little harder than it's turned out. I guess that's good. Okay, so we got this working. Let's just do some arbitrarily deep kind of thing. 1, 2, 3, 4, 5, 6. Okay, evaluate. 1, 2, 3, 4, 5, 6. Number. Okay. That seems good to me. So I'm happy. I don't know. I just want to play with it when I'm at a good point like this. What's the diff here? I could have sworn I pushed that. Did I bump something? Sure looks like it. Join separator that. Yeah, that seems wrong. I hope. Let's run it. Run those tests. Make sure we're okay. All right. So how are we doing on this? Evaluate tuples. This is the third. Only one. Perhaps next month I'll get that right. And the story is evaluate tuple and improve tuple printing. We did that. It's one of those things. I mean, you know, we do this incremental development, and most of the time we move forward. Once in a while we have to do like we just did and reverse a design decision. So my design decision was formatting a value means putting its actual value plus its type together in the string, and it turns out that's not what's wanted. I put this down in this case. If we had got I was going to say if we'd gotten the interpreter working sooner, we would have seen this sooner. But I don't think that's true, because I think what's going on is this is our first compound type, or I guess, is that the right word? Compound? All our types like integer, float, custom value, so far, the concrete types that you can end up with when you interpret something, those have all been simple types, single, integer, float, Boolean. They're all just simple values at some level. Let's see, masturbate. So what we're doing is we're writing an Elm interpreter, and we're working in Swift. We've got a few expressions going, so we can do integer values, floats, custom values, which is like Boolean, if expressions, and some definitions. So maybe a quarter of the language, maybe less. And we've been working on this one for tuples. So line 34 there, you can see 1, 2, 3. We wanted it to print out like that. And we had an old decision that printing out the value of something would print its actual value and its type. And it turns out with compound types, that meant that our one on the left there, 1, 2, 3, would print 1 colon number, 2 colon number, 3 colon number, all embedded in the type, because it's a tree-shaped wrapping thing. And we've gotten that out. We had to back up the design a little bit and take out all those ones that were printing it inside. And what you want to notice is, like, we were in intermediate states. I pushed anyway, but we had one 1 integer printing out as 1, at the same time 2.0 would print out as 2.0 colon float. And it meant that if you used it, it would look weird and wouldn't be quite right. So we definitely had a small, I mean, we've been working, I don't know, half an hour or so. Yeah, so the program is, you put in some Elm code. Let's see if we can do this. It's a substantial program. I mean, this is going to take us a while to get through. You put in Elm code. So we're working on simple expressions right now. So you put in 1, you get an evaluation. We don't have operators yet, so you can't even add things. We're pretty early on, but there is this new type, or new for us, tuples, where you have anonymous records. You just have fields, and you can create these sort of record-like things, record-like values, and we've got those evaluating. So we have a lot of the mechanism for evaluation in place, but we don't have a lot of operators and things like that can do it. The only one we really have right now, if true, then 3, else 4.0. Okay, so the result is evaluate it. It is true. Get 3. It's a float because the 2 branches have to have this compatible type, and you take the sort of union of them. Yeah, so it's got a lot of pieces already. Even, I mean, I don't think they're so terrible. Let's look at integer value. They're expressions, so they're in a big tree. Basically, our parser builds up this tree, and then these functions evaluate them. How do you evaluate an integer? Well, you just return the value itself. So if you got an integer with 3, you just return 3 when somebody wants to know what it is. That's fine. You can compare them, which is more for testing. You can get the string, which we do for printing, and you can force them into a particular type. That's so converting number to integer or float will work. But we just got lambda expressions. So anonymous functions, we can't evaluate functions yet. So that's kind of like, we almost have something useful. We got parentheses done so that we could put a lambda expression in parentheses and evaluate it next or soon. Okay, so if you're interested in compilers or interpreters, this is definitely that kind of session. All right. So what's next? Format type description. Okay. Yeah, we can refactor that. So this was an Elm type. We call this format type. I don't think we have a description. Okay, so let's make, I'm going to split this out again. I'm going to say extension Elm type custom string convertible, which says I want a description. Now I don't know if I can. Unfortunately, the refactoring tools in Xcode aren't so great. So I would like to convert format type to a field accessor, because description, it wants description of string, and we can calculate it because we have computed properties, but format type. Okay, so I would like to convert all the callers of this to use that, and then I can inline it because nobody else is calling it. So let's find format type, and I don't think it's a great naming because it embeds type, and it embeds its type in its name a little bit, but fortunately it makes it easy to find. Okay, so format type, this is nice. Yeah, goes to type.description. My I key is sticky. Okay. That's the definition of it. Input dot description. Same thing here. few tests. All right, I'm going to check without parentheses just to see who else has it. Type. Okay, this should work. All right, and so I'm going to inline this. This is like a cheesy way, but it's calling directly, so I'll do that. And again, that should pass. All right. Rename Elm type dot format type to description. Okay. Let's see. We've been going for a while, so let's take just like a 2-minute break. We'll come back, enforce this semantic rule on tuples that you can only have 2 or 3 values. Surprising to me, but okay. And we'll fix that rule and then wrap up with tuple and move on. So see you in 2 or 3 minutes. Hi, welcome back. All right. We're going to enforce this rule about tuples having only 2 or 3 values. And we will be done with evaluate tuple at this point. So I think we've got tuple here. Well, when you format, let's see. I guess we want to go to the parser. All right, so when you form a tuple, delete that. That. Okay. So parenthesized expression is either a simple parentheses like you learned in 3rd grade or 5th grade or whatever you do, whenever you do, and a tuple that has the commas in it. So down at the end you can see if there's only one, we just return the expression, but if it's more than one, we return the tuple. And the restriction is that this count, it only is allowed to be 1, 2, or 3, basically. Okay, so let's see who else enforced something. I think the if statement did. Let's see. Whoops, we got if statement down here somewhere. Yeah, so I think what we did so far was we just put a kind of try-catchy kind of thing there. But I think we can, I don't think we need to be that fancy. It checked for conditions not Boolean and if then else incompatible. But I think we can just enforce it right where we are. So let's change this into a switch. Expressions.1 case 1. We'll return that. Case 2 and 3. I don't remember if you do it that way. I think you say case on each one. One, 2, 3. And then is it default? Okay. And then we're going to return an error expression. And then we do messages, error messages, dot, and we'll say cannot happen for now. Actually, let me do it this way. Let's do it as a pure refactoring for the moment. Can I do that? Okay, I don't know. I never have used this before, I don't think, in Swift. You can explicitly tell it to go to the next case. Okay, so I want a refactoring first, so we'll make sure everything is still working. All right, and now I need my parser tests, and I want to make sure that tuples can we want a successful parse. Well, okay, let's call this tuple can have 2 values, may have 2 values. And then we'll do one that's 3 values. I'm going to go a little simpler here. 1, 2. Okay. What was that? Still 999. Integer value. I guess it doesn't look any simpler when you come to it, does it? 1. Elm type dot number. And then same thing again with the value 2. And this is number. Okay. And this should pass. We'll delete that. We're just testing more cases, but we'll add a case with 4 and have 4 or more values. And it's almost easier. Check failed parse. We will check 3.045. Okay. We expect this error. It doesn't exist. Let's go over here. Tuple number of values. I'm alphabetizing these for lack of a better way. Tuple number of values is tuple may only have 2 or 3 values. Okay. Test should fail. Good. Okay. And we should get no error at all. Yeah, we should get a tuple. Okay. 3.045. Yeah. Okay, so we got to enforce that in the parser. Now we'll go back to what I was doing before. Path I started on. I was going to return the wrong thing and then return the right thing, but let's just do it in one step. Okay, so 2 or 3, you return a tuple. Default, not 1, 2, or 3, you got an error. Okay, and I've said before, when you're doing the parsing, the actual parsing is pretty simple. You just match these things. You consume them when you find them, when you find a match, and you call a method that corresponds to the rule. This require is another one that matches and consumes. But all the other stuff in here, the error expressions and the cases and catches, that's all error handling. It makes it kind of ugly. I don't know. There may be. It'd be interesting to see if we could figure out a way to make that better. But that's kind of the way recursive descent goes in my experience anyway. You have a pretty simple parser and then complicate it with this stuff. The next step out of it is probably to switch to a table-driven form or something like that, where you can plug in the errors or something. You imagine these tables with 1, 2, 3 pointing to the rows, and then some of them are negatives telling you go to error expression dot whatever. That's the way they go. All right. This should pass. So much for that theory. Okay, is it the parser test? Error tuple is not equal. Okay, what's going on? Expressions.count 1, 2, 3 default. All right, let's. I guess we'll stop here. Oh, probably. Maybe just run the one function, one test. So expressions is the accumulated values of the tuple. All right, and we can see expressions has one value, so it's not our test we're looking at. Let's run this test. Okay, expressions has 3. Did I put 3 in my thing? Ugh. Let's keep it to numbers and just make it simpler. Okay, I had 3. 3 is legal, 4 is not. And continue. All right, okay. Enforce rule that tuples may only have 2 or 3 values. All right, and back here. Okay, so I was thinking there's still some stuff in the way our interpreter view works. Well, okay, let's do trim input first. Let me take the easy one. Okay, the trick is, well, we'll run. Okay, so if I hit return, unfortunately, I need to make a multi-line statement because Elm statements in general can be multi-line, and we know later on there's something about you got to line up certain columns and stuff like that. So it's kind of a cross of Python has that restriction too. You got to line up columns. But if I hit return instead of evaluate, and even if I do it a couple times, it looks goofy. Okay, so I would like to just trim off the extra stuff at the end. And same thing if there's something before it. Yeah, that's probably correct. We don't handle leading spaces. So, but at any rate, I would like it trimmed on the input side and then dealt with. So we can let's oops. We'll start another story down here. Okay, so trim input. In multiple lines of text, evaluate as you go. That's not even legitimate, so we can't do that, I don't think. We might be able to figure out a way, but it's probably not correct. All right, let's close all these again. Let's open interpreter view model. And it's test. Tests. Okay. Let's see. So this basically checks. Yeah, so let's just give it some input. All right, so if we give it the input with some new lines, let's see, trims its input. And actually, we'd be fine with it here. I think we're going to get, we want that. Now, I mean we have to put a new line in at the end, but I think we may already do that. And I'm going to move this up. Interpreting logs, I think we'll talk about the input then the output. All right, and run, and I expect this to fail. Okay, so it failed with a bunch of extra spaces instead of just one. Into our error, yeah, because the leading stuff. All right, so let's go into interpreter view model. And we got our input. Let's just do input.trim. Oh, we don't have a trim? What was this? Am I Swift string trim? I'm going to have to be explicit, I think. Trimming characters in set with ns whatever. String by trimming. 3 plus my string in white spaces and new lines. Oh, okay. Input dot trimming characters in white spaces and new lines. Okay, that's not too terrible. I don't think I need to do anything on that. All right, I think that should pass. We get hard problems and sometimes easy problems. I shouldn't say it till it passes, right? There you go. What do we got? 42 blah 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 number view model dot evaluate. Well, let's extract it. Oh, well, it would be nice to put that in our yeah, let's do that here. Evaluate trimmed input. Okay. All right. Not quite as easy as I wanted. In user interface, trim white space of incoming expressions. Cool. All right. Now, okay, so this one, the next one I'm worried about, let's see. All right, see, it puts it in here, but it doesn't take us to the bottom. And I would like it to do that. And this is, I don't know, these are these frustrating UI things. You know, I would like to just tell it, like, you know, stay scrolled to bottom, auto scroll to bottom, or something like that. It doesn't sound like that's a freebie. I did find this researching at some point. Programmatic scrolling, working with a proxy to scroll to known child views. Ugh. ID. Yeah, I've seen something like this. Yeah, so you put your scroll view in a scroll view reader, you create some element, give it an ID, and then you can force that to scroll to the ID. Proxy. Well, he knows the proxy. I don't know how. I guess we'll have to pass. We'll have to pass the proxy in and the ID. I mean, at that point we may as well. How do we trigger that? Well, this isn't as helpful as I wanted because this is the button is going to trigger it. And the button has access to all that stuff. Like, where would I call that in my normal case when there's another button outside this object? Yeah, and this one, you've got a bunch of views. I don't know. There's got to be another way to tell a view to auto scroll. Maybe I should say Swift UI to be more. Yeah. I don't know. It doesn't sound. Seems like a hard way to go. Scroll view reader, yeah. Value dot scroll to 8. These all seem to be variations on what I have there. Everybody likes the same example. Anchor scroll view dot scroll to. Oh, no, that might be. Oh no, that's coming off the reader. Well, let's see if view Swift UI scroll view. Let's see if it just has something to force things down there, maybe. No, not a lot here. Show indicators. By content and behavior of the scroll view. I mean, it's weird to me. Like a scroll view must have something to control that. Conforms to view. Maybe there's something up here. Scroll view reader. Back to that thing. Programmatic scrolling. Working with a proxy to scroll known child views. Okay. Only actions created within content can call the proxy. Let me read that again. You may not use the proxy during execution of the content view builder. It's a runtime error. Only actions created within content can call the proxy. A view's on change of perform method. Okay, that's possible. On change. Let's see. Well, let's see what we can do with it. This is content view. Let's just we'll do a tiny little spike. Of what? Swift UI text on change. On change of name and then do something. Okay. Of view model dot session, and we will print text changed. Okay, let me hide this. Type block cannot conform to equatable. Well, is this, these three lines are messing this up, right? Yeah. Okay, so text field. Well, text field. I mean, this definitely changes. ViewModel.Session is an observable object. Here. Session published. Okay. I don't think it's going to help to move this up, but I'll try it. Directly to the binding rather than to the view. Well, text field calls on change, but oh, this thing does not. I don't know. We're not getting anywhere we can hook in. Okay, let's try a different search. Whoops. Oh. I'm lost here. Why did this move windows? Okay, so we're trying to say Swift UI update view when text changes. Yeah, modifying state during the view is not a good thing to do. Okay. Okay, a state object is going to be somewhat like the published stuff. Text model.title updates the view when the title changes. Yes. Well, let's get to this Swift UI text object directly. Creating a text view. Styling, I don't care. Controlling the layout now. Well, we'll come back to view modifiers. I don't know, maybe text editor? Can we make a... Seems like we went down that path and backed out. Okay. View modifiers, we want change. On change. Yields a view. Okay. Can I say on appear? And is the variable the thing that's messed up? Perform. Maybe I just messed up my thing. Change of view model.session. Let's do nothing. Type cannot conform to equatable. Only structs can conform. Cannot convert string to expected argument type. Nothing. Is that going to help any? It is. So normally we pass. Okay. Still learning how this works. Okay, so shoot, I wanted to run. It's nice if it doesn't break tests, but this code isn't The UI code is not directly tested, unit tested. Okay, so we'll run. And if I do my evaluate thing again, whoops. I should have seen like 9 helpful little highs. Okay. I don't know what I did there. So it said the value So now I guess I want to do I'm going to have to put that scroll reader thing in, right? So theoretically, this thing has it has the value. That's fine. We don't really care what the value is. All right, let's get the scroll reader example going again. I don't know if I kept that. Yeah. Scroll view, so you put the scroll view reader around its contents with a value, which is the proxy. Did we get something similar? Nope. Okay, here's Apple's example. Scroll reader goes around the scroll view in their version of things. Okay. So we'll take this and wrap it around with a brace at the end. That should be a neutral behavior for now. Well, I can even include the spacer, right? And give this thing ID bottom ID. They got to declare it somewhere, yeah. Okay. That should be neutral. Let's format it a little better. Oh no, that spacer's not going to work there like that. We'll have to move this up. That's not going to help. Okay, let's put this back. And run. So I have the proxy, but I'm not doing anything with it yet. Okay, 1, 2. Okay, it's there, but it didn't scroll there. Okay. So now in here, let's format this a little nicer. Okay, so theoretically, we have access to the proxy. We can say scroll to bottom ID. I don't think animation is going to help the process here. Now this, I think maybe we want to do after the text. Well, we got a VStack in place. Let's put our put a new frame of spacer. I don't know if I can say 0. Whoops. ID bottom ID. Okay. Frame height 0. I may have to make let's make that 1 just to make sure it's something there can grab. Okay, so the proxy gets passed in the scroll view. It's got the text and the spacer. We're saying whenever the text changes, scroll to the spacer. Can I give this a color? Color. Foreground color, blue. Cool. All right. Oh, did it again. It's probably a good sign I'm like running tests. But let's run the app. Now, I don't see a little blue thing there, so that's a little discouraging, but we'll see what happens. Nothing. Now, why don't I see a blue thing, right? Spacer, maybe it has nothing in it. Let's put something a little more visible. Text this. All right. Run. Well, it's staying at the bottom. I'll give it that. 3, 4, 5. Oh! I think I just crashed it. Now, these constraints, they seem like they have nothing to do with us, but yet here we are crashed, I think. I can get a stack dump. Let's try that again. Now, it's interesting that some of these examples seem to put the scroll reader inside. It's kind of hard to know. All right. 1, 2, 3, 5. Well, the good news is it didn't blow up. The bad news is it didn't scroll where we wanted. We know it's calling. All right. Well, I think we've been going for a while, so let's take a break. Couple minutes, and sometimes that's enough to clear my head and figure out what's going on. But anyway, see you in a couple minutes. All right, welcome back. I do see this. You can use scroll to anchor. We didn't put an anchor in. Let's see what it's saying. Okay, so unit point. If nil, it finds the container of the identified view, scrolls the minimum amount to make the identified view visible. You can specify top or bottom to align the bottom of the identified view to the bottom of the scroll view. Well, I don't think I'll try bottom, but I don't think that's quite what we want. Anchor bottom. Is that legit? Dot bottom? I'll train myself someday. Okay. Yeah, it's already not doing that. Okay. Well, I mean, this is... I don't have a lot of luck with the playground feature, but let's see if we can make that go. New playground? Single view sounds fine. Oh, we're back to this thing. I wonder if the only one getting that. Okay. Playground. Can I add subview body? No. Namespace. Okay, that's not going to be. Okay, I don't see one in there. I hope they update this thing soon. I get this really weird. I still see stuff flashing. Okay. I don't know. Let's find another example. We may let this go again. Okay, this one, the scroll view reader is inside. Scroll to 8. I guess that's that. We have an ID instead. Okay, so let's flip those two and see if that helps anything. Like I said before, this Hacking with Swift site definitely has had good answers for things I've looked for before. Okay. Make sure everything's lined up to what we expect it to be. Scroll view vertical reader. Okay, let's run. Hey, happy geek guy. So we're working on an Elm interpreter written in Swift, and right now we're trying to solve some user interface problems that we'd like things to scroll as it produces, answers in our code. Okay, this is looking different, so maybe it'll be better. But now, am I bumping something? I must be. Okay, so it's trying to scroll. I don't know. I feel like maybe my hand's drifting to a corner or something, maybe. Okay, it's not scrolling where we want. Okay. So what we're trying to do is make it so that every time it finishes, every time it sees a change in the text, we want it to scroll to this item, the equal signs at the bottom, and eventually we'll blank those out. But embed a scroll view reader with the scroll to, just providing the anchor. Now number 2, I mean, I guess that's item 8 in there. That seems really weird. Scroll to. Okay, I guess we want an ID. There's no way around that. I don't know. There seem to be a lot of people confident that that will that will get us to the right place, and yet it doesn't seem to. Okay, so scroll Swift UI, scroll view, force scroll to bottom. Scroll list. We don't really have a list. So added a scroll to bottom. I feel like it should be easier. I feel like the old scroll view in the UI kit, I thought just had a scroll to position or scroll to bottom kind of thing. It seems it is impossible. Yeah, okay, that's my experience so far. Okay, that looks like it's too old to be correct. Yeah, I mean, it's for something that feels like it should just be a built-in function. It's really kind of weird. Weird that it's not. Okay, I may have to do the more complicated thing. Scroll viewer doesn't sound like, yeah, it's .NET. I saw Xamarin mentioned. Not possible Xamarin either. Okay. Swift UI 2, I don't know. That's the old solution they needed. This has been in the new one for a while, this proxy thing. Scroll view starts at bottom instead of top. That seems like an improvement from my perspective. All right, some unrelevant. Okay, so I don't know what's going on that's not making this work. My thought was there's other kinds of text things. I think it's text editor. Which I think is what we may be using on the bottom. Display and edit text. Scrollable, but okay. Can I disable it? Okay, let's see what we got. Is that what we use down here? Yes. So it needs a binding. All right, let's keep this here for a moment. Let's try this text editor view model.session. Border. take this out. Let's just substitute it and see if that kind of works first. Okay, so I'm not going to worry about disabled or not. Oh, text. Huh. Okay, something really weird. Okay, I got the text editor. Proxy got scroll to. Bottom ID. It doesn't. Well, let's swap these two again, just for possibility's sake. I don't know. It's weird. The Apple example is completely backwards from the other two. I don't know why that would work that way. We're running. It looks better. Well, so much for that. Okay, I guess the text view editor is not an improvement. Okay. I don't know what I just did. Well, I'll put a tab in. The only way this would work is if I got used to the new stuff coming up to the top. I don't know, that would be different. Not wrong necessarily. Okay, let's see where we are. Okay, we've got our attempt. I'm going to leave it for now. It doesn't seem worse. Let's check this in. Try to get scroll to bottom in user interface. Unsuccessfully leaving that in place. Okay. Scroll view reader unsuccessfully. Okay. I'll just put this in here just for completeness. Okay, so I'm going to push this. You can see the UI stuff. I want to use Swift UI, but boy, they make it tough sometimes. Things that you would expect would be pretty simple aren't there. Okay, let's go back to things from a language perspective, and let's bring up Elm syntax. Okay, so what I want to do is find the things that'll teach us the most, the quickest. I don't think strings are super interesting from that perspective. The only complication I see with them is they're strings are like comparable and appendable, and there's these other sort of pseudo generic types that they conform to, I guess. Operators could be interesting, but I think operators are kind of an example of function calls. Lists, I think, are a sidetrack. We have the if. Case is a fancier if. Maybe something there because there's some matching that we don't support yet. Records, no. Functions, I think maybe what we want to do. Yeah, the other one is you have these. You can wrap an operator in parentheses. We don't do the syntax for that, but if you do that, you turn, well, it's a function of however many arguments it had too, I guess. All right. So I think functions may be the way to go, and I'm kind of dreading. There's stuff I'm not understanding, so that's going to be a challenge. Okay, so I think function definitions can wait till we handle function calls. So again, this is my like stack of stuff down to the dashed lines, which is what we've done. So I think we'll look at function calls, then function definitions, and then maybe tackle this again. I may do some research and just see if I can figure something out. I don't know. I never know with this. Like, if you stand around and watch me research, is that helpful? Seems a little off, but okay. So parse function calls. Decide how to handle multi-argument functions. Okay. Right now we have no functions. The only function we have are those lambdas. So we can say lambda n goes to n. I guess we could say lambda n goes to 3. So you could have something that takes an argument and throws it away. Okay. And then from a syntax point of view, it looks like expression, 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 expression. So multiple expressions in a row. Now, where's our parser? So up at the top level, when you say parse, we say parse an expression. I mean, now everything in Elm is kind of an expression, so it's not totally bizarre that this is how that works. So notice line 37 through 41. These are all the things that can be expressions. Okay, you could have an int, a float, a name, or a left parenthesis. So far, I mean, we'll add to it. A lambda is an expression. How does expression start? It looks at these tokens. Well, I would say a lambda expression is an expression. So let's start and put lambda down here, and then in expression we'll make it call lambda. So we'll add token.lambda. We'll take it out of here and we'll call it down below. Where's expression token dot lambda returns a lambda. All right, this should pass all our yes, it should pass all our tests. Okay. The pause, I guess, was we don't have a test that looks for an expression. Looks for an expression. let's see. So lambda, it passes in a lambda to an expression, but I think that'll be okay. Now, back to the top level parse. So right now we just say parse, look for expressions. Wow, I mean, expression is sort of everything. I mean, an if is an expression. Let's try it. So I should be able to say if true, then if true, then 3, else 4, else 5, and I should get 3. Yeah. Well, we're kind of learning something here. This is an expression. Everything going on is like delegating into my expression, except for these top end of file and errors that are kind of special cases. Well, I'm going to do the same move. We'll see. Reserved if this, that comes out. Parenthesis lambda if do an if statement, and well, that's really an if expression or a variable. Let's add that one next. I think that's more like these. No, is a lowercase name. Yeah, it is. Okay. And we'll need this. And don't need this. Oh, we already had lowercase name. What did I just do? Token.lowercase name. Okay, I moved that up. Need this. Don't need that. Token.lowercase name. Where's my variable method? Variable expression. Name plus equals expression. Oh, this is hard. This is what I'm talking about, the ambiguous nature of these grammars. Let's undo that one. See, I don't know. Like this, I can say a equals 3, a. I get the name back. That's a lowercase name. I had lowercase name in here. So I had it in expression, and all you do is get a variable. But down here, I got a lot more going on. Variable expression name equals expression. Okay, get token. If it's an equals, do get next token. And return a definition, otherwise variable. Yeah. This is where the grammar being kind of ambiguous. So when I see a lowercase name, I don't know if it's a name. Yeah, so I see name equals expression. I know that's a definition, but I don't know until I peek at the equals. So you can kind of see that here. If it's an equals, oh, then it's going to be an expression, which we do parse lowercase names in. Otherwise, if it had the equals as a definition, otherwise it's just a variable, which is kind of what expression did. It just said, oh, you got a name, I'll call it a variable. But this case, name plus, can you just have a name? Ugh. If it's all names, it could be a definition. If it's not, it could be a function. Oh, this is terrible. Okay, so a function equals lambda n goes to n plus 2. Okay, if I say function a, get 5. I see two names in a row. I could see function A3. I don't know what that does. Okay, are there missing commas or parentheses? Expects one argument. What if I say function of A equals A plus 7? That's... Okay, you did define it already. Well, if I say function x equals x plus 7, right? You can't tell it's a definition until you see name equals. But structurally, if I see function a here, I see name. Could be name if this thing had a lot of arguments. Name. It's not till I see the equals that I know I have a definition. If I don't see an equals, like, what am I going to see? Like, if I saw name. Yeah, if I see function, let's let F2 equals lambda n goes to n plus 1. Can I do that? N plus 1? Okay. So F2 of 3, F2 of A, these are calls. F2 Z breaks. F2 Z equals Z times 3 is fine. So normally, can I see a list of expressions? Well, when I see a list of expressions, I guess that's the question. I see a list. I mean, I can do this. N plus 1 applied to 7 gives 8. So expressions can be functions. Expression, that should be fine. To make a function call work, I'm going to have to allow expression. But if I also let variable mean something, I guess if I see expression equals, I got a definition of some sort, and I got to check my stuff. I can't say lambda n goes to n plus 1 7 equals 3, right? That doesn't mean anything. Okay. So function call. So maybe it's like this. Function definition is expression equals expression. Equals expression, 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 expression. And that's a definition with restrictions that we'll have to figure out. But if I just see expression, expression, expression with no equals, I'm going to evaluate it. Wowzers. Okay. So again, I may have to back up a little stuff here. This thing, it's trying to handle the special case, name equals expression, I guess. That's the, it let us move forward with some definitions and some evaluation, but it's artificial. It's not general enough. And this is really the true situation. Name plus equals expression plus is a function definition. If they called other things than names, I mean, basically I have to check that the defines, the things on the left can be names for now. But, oh man, we saw other stuff. So crazy. Where's that cheat sheet? I think up on the top corner here. We got AB. I'm worried about these tuples showing up. Where's a function that uses it? Well, you can pass a tuple to a function, I guess, is my concern. I don't know where I thought we had an example on here. Well, yeah, sum A plus B equals A plus B. Okay, so a tuple is an expression. So a tuple consisting of names only is legal in a function definition. If it had a value in here like 3, that would not be legal, or false, capital expression. Okay, so I think our grammar has got to be expression plus optionally equals expression plus. Okay. Yeah. I don't like being so complex, but I think that's what it is. Okay, so I'm trying to refactor this thing because I think we're making some changes here. All right, so I would like to say if you saw well, maybe definition is what needs to be done. If it's just expressions, it's an evaluation. If it's expressions equals expressions, it's a definition. And so at the top, I have to be looking here at name and decide, is it this case, or this case? And I don't know if I can tell until I parse the whole thing into expressions and I saw an equal sign or not. And I don't know if an equal sign inside things is allowed. I don't know what I can do. Can I do x equals y equals 3? No. Okay. That helps a little. I think I'm still parsing the x. It's supposed to be a definition. Okay. So this is saying, okay, this is one expression. I think expression stands alone is fine. I think we've got something. I think our case down here, I'm going to bring it back up. Variable expression. I think this thing is the complicated case. The complicating. Okay, so if I see a variable by itself, when I go to parse, all right, so I'm allowing, okay, here's a question. Does a definition have to start with a lowercase name? I don't know. I think maybe it's always, I mean, whoops, functions seem to, I mean, they do start with that, or there's a reserved word. We're not going to look at the reserved word case. ToString myString equals string. That's another example of using a tuple, I think. Maybe not. MyString we decided was a function of some sort. I don't know. It's all special cased, I guess. All right, but every definition we're seeing is a lowercase name followed by 0 or more other names. So here's a 0. Whew. Okay. So if it's a name, it may be a definition. I don't know, I'm spinning around, I know. If it's a name, it may be a definition. We won't know until we've parsed down a bunch of other stuff. If we see something that's not a name, well, it could be a tuple. I don't know if there's other stuff it could be. If it's not a name, then it's going to be a function call of some sort. Okay. I'm trying to get there in a small, safe way. I want variable expression. I mean, variable expression is a possible function. Okay, what I'm after, I guess I'm after this case. I don't want to do a lookahead, an arbitrary lookahead. I guess that's the real thing from the parsing point of view. You know, if it's one or more names followed by 0 or more names, that name plus in 57 can get arbitrarily long, and my parser only wants to look ahead a little bit. It's one to look ahead one. So that tells me I kind of need to parse name plus as a list of expressions, and then when I see an equals, I know it's supposed to be a definition, and when I don't, it's supposed to be a function call. Okay. Now I'm not sure how to express that with what we have now. I don't think this is, well, lowercase name, return a variable of name. I mean, that's sort of assuming if you call an expression calls an expression, 3a plus and it sees b, It's like, oh yeah, I would definitely want to treat it as a variable in that point. It knows it's got a variable. Okay, but I think we want to allow this name plus equals expression plus thing. And I think it's going to have to be expression. I don't know. I guess it's time to write a test instead of stand here flailing. Okay, parser tests. So let's find our definitions down here. If type plus int. Here's a definition. Okay. A variable reference. Yes. So if I see multiple expressions left of equals. If I see function x equals through, well, let's make it x for now. Then I expect I'm expecting something more complicated than our current definition. What I'm really expecting, maybe it's really maybe too far. I expect to see definition x is a lambda. Do we say lambda expression? Lambda expression. Lambda expression. No, I expect function to be a lambda expression with x and the value x. 3. Okay. That's what it means to define a function, I think. All right, this should fail, regardless of, well, we'll make this variable x just to be consistent. All right, it's defined function as variable x. We're losing the right hand of the arguments. Like, I don't even know. I want to get us to the point where we can parse this thing and then worry about the semantics. Expression is not equal to variable function. So that means somebody's not doing their printing. Let's I guess we're going to have to find out what that value is. Step into. Check successful parse. We'll do a parser of input. Okay, now if I print, oh, that's filter. if I print parser.parse is a generic. Oh, it's a variable generic type function. Yeah, okay. So variable. Why didn't variable print as the thing it was? Let's see what expected is. Expected is a definition. Okay, so let's go check our definition. It may be that definition is not printing correctly. Yep, I see no as string here. Okay, so let's worry about a definition test. I'm just kind of stacking this up. Symbol table X, assert equals result. Okay, I don't care about that yet. I just want to see test description. And we'll just use variable. Y. We'll take out the evaluate. Okay. And then assert equal. We want result.description to be definition X variable Y, I think. To fix the quotes. It might not even be, I don't even know if they're quoted. All right, I expect this test will fail. Oh, not because of that. Expected parens. Okay, expression did not come back as X, Y. Definition of definition. Okay, so as string, we want to return definition, and then we want the variable, the name, and then we want expression dot description. Okay. Should still have one failing test, but I'm hoping the definition tests passed. Two failures. Okay. What are we getting? Variable Y. Oh, so it does put the quotes in. I don't know that we need those quotes. We'll stack this up a little. I don't like stacking these, but I don't know. Do we have a variable tests and String, I'm going to take these quotes out. This test should now fail. And a string will take out the quotes. There may be a few other places that fail now. That's what I mean about stacking. It'd be nicer to just get them all together. All right. Let's disable that and continue. Okay. Well, let's see what we got here. Definition test, I'm still... Okay. Where's variable tests? That passed. Okay, so that's good. Function call. Okay, he's got... Well, this one definitely comes off. All right, any others? No. And description... Variable y. Okay, I think we'll try again. Did I leave off parentheses? No, I expect 2 parens. Definition. Name. Yeah, 1 more parenthesis here. All right. Who's my holdout? Parser tests. Variable x is not equal to variable function. Okay, that's the test we started with. All right, so what we did was we got printing working a little more like we expected, but our call is not working yet. So function of x, we don't really expect it to. I mean, this is not right for an assertion. This is, but we know we have absolutely no mechanism for it. This is still correct, I believe. Okay, so I think we're gonna stop here. I'm gonna take this out. And let's assert the real thing. I think what'll happen, this will still, whoops, 1 more paren. Yeah. All right. This is going to fail big time because we don't turn functions into lambda expressions. We don't even parse this correctly. Okay, so definition, yeah, so the way we parsed it is we looked and said there's a variable function that looks like a variable, let's call it a variable, and this other junk, it's not an equals, so we don't think it's a definition. That's probably the best place to leave off for right now. What I think will happen is we're going to have to rejigger the parsing to really handle this expressions plus 1 or more expressions equals 1 or more expressions. We're going to have to make it handle that parsing, and then we're going to make it handle the definition. And that'll be pretty ambitious. I don't know that we'll finish that tomorrow, but we're back into evaluating functions, so that's probably progress. It is progress. I shouldn't say probably. That is definite progress. And once we have this, we have, sort of a mini language pulled out of Elm. If we added operators, you would pretty much have everything you need to do stuff. It's not as nice as all the record types and lists and all that stuff, but you probably could do something in in infinite arithmetic or something, and make it work for anything. We're almost there. We definitely have a lot of work in expressions, but it's progress. All right, so we'll pick up there tomorrow, 1 to 3 p.m. Thursday Eastern time, and make that go. And then I'll just mention I've got a course or a workshop coming up, a couple sessions in March later in the month. So on my website, you can see a description there. If you're interested, please sign up, and I'll see you in the future. All right. Thanks for joining me. Have a good rest of your day. Bye-bye.